Hello, everybody. It's Mr. Odom. I hope you are having a great day. I am going to cover section 3.1 out of chapter 3. It's titled Algebraic Expressions. And chapter 3, you're going to hear me say this throughout the whole course, is probably the most important chapter in the 7th grade math book. When we finish this chapter, I hope you guys are comfortable with solving equations because solving equation comes up a lot as you're taking algebra, geometry, algebra 2, and those of you that go on to higher math. So I will get started. As usual, you will need pencil, composition book or notebook paper, and a calculator. And the learning target for this video is I can apply properties of operations to simplify algebraic expressions. All right, so for the first part of the lesson, there's vocabulary. And I want you guys to start getting in the habit of writing vocabulary in your composition book. So the first vocabulary word we have, you see highlighted in yellow, is like terms. And what are like terms? I will highlight what you need to write down. Like terms are terms that have the same variables raised to the same exponents. Constant terms are also like terms. Okay, so that's the definition. I'd like you to pause your video here. This is an Edpuzzle. It'll pause right now. And I'd like you to write that definition in your composition book. Okay, now that you've got that written in your composition book, what am I talking about? Here's an example of terms that are like terms. Let me write some down. Let's see. So x and 3x and negative 7.146 repeating x and negative 2 and 6/27 x are all like terms. And the reason they're like terms is because they all have the same variable, x, raised to the same exponent. Let me add a term here to this list that's not a like term. 41.7 x squared. Okay, this is not a like term. Why? Because the variable here is raised to the second power. So this is how you can tell if terms are like terms or not like terms. And you should be able to identify like terms in an algebraic expression. So let's practice. So I worked out problem 1, where it's the directions say identify the terms and like terms in the expression. And how do you say this expression? To say this expression, you basically read it from left to right. It is y plus 10 minus 3/2 y. So if I want to write down the terms, I just do that here and I separate them with a comma. Something that I want to point out to you is that for this term, negative 3/2, notice how when I read the expression to you, y plus 10 minus 3/2 y. Here I said minus. So if I'm reading it to you, then this is a subtraction sign, and that's how you read it. But if I am identifying like terms or terms in an expression, then now I say negative 3/2 y. Okay, so in this chapter, you're going to learn that sometimes this will mean minus, and sometimes this will mean subtraction. The way I remember it is it means subtraction if I am reading an expression. And it means minus if I'm looking at the terms in an expression and there are negative terms. Okay, so let's look at the like terms. Well, why are these like terms? We said above, like terms are terms that have the same variables raised to the same exponents. So when I come down here, this term and this term both have the same variable, which is y, raised to the same exponent, which it's not written here, but it would be y to the first power because there's just one y there. Okay? So what I want you to do now is go ahead and pause the video, and I want you to work out problems 2 and 3 on your own and write your answers in your composition book. If this video is in Edpuzzle, the video will stop now. Okay, so we're back, and hopefully you have worked out those problems. I'm going to scroll down and show you the answers to problems 2 and 3 so you can check your work. Okay, so for problem 2, the terms are 2r squared, 7r, negative r squared, and negative 9. I guess I should write down the expression. It was 2r squared plus 7r minus r squared minus 9. Okay, so here are the terms. And now the like terms, there are 2 of them, okay? Because 2r squared and negative r squared have the same variable raised to the same exponent. They are like terms. 7r and negative 9, those are not like terms, okay? They are not. For number 3, here are my terms, 7, 4p, negative 5, p, 2q, and in this problem, there are 2 pairs of like terms, 7 and 5, and 4p and p. Okay, so let's move on to the next part of this section, which is very important. So we've got another definition. An algebraic expression, which is what we're working with, is in simplest form. There was another time we saw simplest form, and that was if we had fractions. So if I had this fraction and I said, hey, write that in simplest form for me, please, you would write it like this. Okay, so we've seen this term simplest form before, and we applied it to fractions. Now we're going to apply this term, this word or this phrase to expressions. So an algebraic expression is in simplest form, and here is the definition: when it has no like terms and no parentheses. So I'm going to pause the video here, and I want you to write the definition of simplest form in your composition book. If you're watching Edpuzzle, then the video will pause right now. All right, so hopefully you have that definition in your composition book. All right, let's see, let's simplify expressions. There's some steps that I wrote down. Let's look at this study tip. It says to subtract a variable term, add the term with the opposite coefficient. So it's basically saying if you're going to subtract a term, add the opposite. Turn the subtraction into addition. Okay, that's what this is saying. It's basically, I don't even know what's that a picture of? That's not an arrow, Mr. Odom. This is basically saying to add the opposite when you are combining like terms, which is what we learned in chapter 1 when we learned how to subtract integers. So let's practice simplifying an expression. You see an example here, number 4. I wrote it down, and here are the steps I'd like you to follow. The first step in simplifying an expression is to identify the like terms. And the way I do it, and you may have another way, you could use a highlighter. So here I'm highlighting like terms because I have all these different highlighting colors. I can do it this way. Sometimes people like to underline. So I can underline like terms like this, and maybe these like terms, I put 2 lines underneath. Whatever your style or method is your style or method. I'm going to use circle, squares, and triangles just because I don't know. I just like circles, squares, and triangles. So step 1, identify the like terms. And this is how I identify them. Step 2 says what? It says group the like terms together, which means treat these terms like they're kind of like puzzle pieces and you can move them around. So I put the like terms that are in boxes together, and I also put the like terms that are in circles together. And the reason I can do this, and I don't have time to talk about it now, but it's because of the commutative property of addition. That it says when I add things together, the order that I add them doesn't matter. Okay, the third step, another important step in this process, is to go ahead and combine like terms using the rules from chapter 1. So if I'm going to combine 14 plus 8, same sign, add and keep, different sign, subtract, keep the sign of the bigger number, then you'll be exact. Remember that song? It still lives. And these two are positive, so I know I'll get positive 22. Here, negative 3z plus z. So this is the same as negative 3z plus, and if there is no number in front of the variable, I can always put a 1 there. Because remember, this is just a multiplication problem, negative 3 times z. This is also just a multiplication problem, 1 times z, which 1 times z is just z. So don't forget this trick with this magic 1 here. And now all I have to do is combine the coefficients, negative 3 plus 1. And what is negative 3 plus 1? Well, I remember from chapter 1, same sign, add and keep. Part of the expression, you use the part of the song that says different sign subtract. So I'm going to subtract the absolute values, and I keep the sign of the larger absolute value. So that's why this would be negative 2z. So my final answer is going to be 22 minus 2z. All right. And I can say that it's the final answer because I already know the answer. But if you don't know if this expression is in simplest form, then you have to ask yourself 2 questions. Question 1, are there parentheses? So are there parentheses up here? No, there are no parentheses up here in this expression. The next question, are there any like terms? Again, I say to you, no, there are no like terms. Okay? And if you answer no to both questions, then your expression is in simplest form. Okay? So I took a while to go through those steps because they are so important to help you understand how to combine like terms. So I want you to do is pause the video here and work out problems 5 and 6, which are right there. These 2 problems, work them out in your composition book. We'll be back in a moment. And if you're watching this in Edpuzzle, then the video will stop now. All right, so let me come back down here. Let's look at the answers to problems 5 and 6 so you can check your work. 6.8x minus 5, and for number 6, it was negative 3/8b. Okay, so those are the answers to problems 5 and 6. Here is some other expressions that you have to do a little bit of work to at first, because notice that in these problems, I have an expression where I'm going to have to use the distributive property. Okay, so how do I use a distributive property? Those that have forgotten might remember those arrows, but basically, I'm working out problem 8. The way I read this problem is -2 times the quantity g plus 4 plus 7g. So since this is a multiplication problem, I have to distribute the -2 with the g and with the 4. And that's what I do here. -2 times g, and then I'm -2 times 4 plus 7g. And then I just go through the steps from above. Step 1, I identified my like terms. Step 2, I put those like terms together. I combine them. In step 3, I have my, step 2, I put them together. Step 3, I combine the like terms. And then for step 4, I have 2 questions. Are there parentheses? No. Are there any like terms? No. Then this answer is in simplest form. Okay. So again, pause the video here, and I want you to work on problems 7 and 9. And if you're watching this in Edpuzzle, the video will stop now. All right, we're back. And the answers to problems 7 and 9 are here. So check to see if you got them correct. And I hope you did. So this is a little bit longer video, but this is an important video. You have to be able to manipulate expressions, combine like terms, ensure your expressions are in simplest form, because that's going to help save us a lot of work when we get to future sections in this chapter and in the textbook when we are solving equations. So that's all I have for today. Hopefully this video was helpful. Give me some feedback, and I will see you guys soon. This is Mr. Odom. I am out.